One of the really incredible things that we have a heritage of doing here at the University of Arizona is building instruments for spaceflight. We were able to draw on that wealth of experience when putting together a plan for how to take these seismic sensors, built mostly for the oil and gas industry, and mature them into something that could survive spaceflight, as well as some intense conditions on other planetary worlds. We were really excited by the possibility of NASA sending a landed mission to Europa. One of the payloads or the instruments that they wanted to include on this mission to Jupiter's moon Europa was a seismic instrument. This is something that can measure ground motion. It can measure the response of any planetary body to shaking from quakes or maybe even impacts. We wanted to see if it was possible to build that type of instrument here at the University of Arizona. And we basically started from just a concept on paper and have spent the last 8 years or so building up this program.
This is what we lovingly refer to as our beer can. It's about the size of a large beer can, and it is our seismometer system. So this is our seismometer. Inside our main sensor, the large one, there's 3 of these.
So the seismometer to investigate ice and ocean structure is this project that we stood up to develop a spaceflight seismometer that was well targeted to visit Jupiter's moon Europa and could really be used at any icy ocean world in the outer solar system. The seismometer to investigate ice and ocean structure encapsulates our work to try and really test how would you do this in real life if you're going to another world and you have one shot. In the case of the moon, we don't have a great sense of what is happening at its core. The little bit that we have learned from seismology suggests that there is an inner core. It's solid, kind of like Earth's, but it might still be chemically segregating. So there might be a layer of partial melt in the interior. And that's all based on seismic data from the Apollo days. So if we can develop a better spaceflight instrument than what was sent out with the Apollo astronauts in the 60s and 70s, and send that to the moon, we'll be able to really advance our scientific understanding of its interior as well. And it's accessible to us. We plan to send astronauts there through the Artemis program over the coming years. We want to put our seismometers in the hands of these astronauts and see, what can we learn with this generation of instrumentation.
If we were setting up a seismometer on the Earth, you could do it in 30 minutes, whereas on the moon, with the astronauts only being able to carry a certain amount each time they walk and having to rest every 8 meters, it's going to take them 2 hours. So the Artemis astronauts are going to be drilling into the surface of the moon to collect rock samples that they'll be bringing back to Earth for study. Now, we've designed our seismometer to fit into one of those drill cores. So when we're training with the Artemis astronauts, we're going to be doing it in their suits so that we can get an idea of, well, can they bend down and put this in? If all the stars align, we should have our seismometer package ready for Artemis in 2025.
We want to understand the interior of other bodies across the solar system. We can definitely send spacecraft with cameras to map out the surface of these other planetary objects, but it's a bit more difficult to get a peek at their interior. And so seismology is the ideal tool to study the interiors of planets. In the case of Europa, we were really interested in understanding, what does it look like at the subsurface? How deep is its ocean? And could its ocean be deep or shallow enough to possibly sustain or prevent the formation of life on that body? When we look at objects like asteroids, which we are also investigating the development of seismometers for, we're really interested to determine how the interior is structured in an asteroid and what that means if we ever have to develop some sort of mitigation technique for an incoming asteroid that might be a threat to our own planet. So across the board, we want to understand the interiors of these bodies. The scientific motivation can vary depending on the type of body, but seismology is the best tool in order to get at the interior.
Hi, I'm Tom McNamara, host of Arizona Illustrated. Thank you for watching this story from our show. And for more local content from Arizona Illustrated, just click right here.